Understanding compiler in modern software development. Assalamu alaikum and good morning to everyone. Today we step into the heart of modern software truly works, the compiler. Every program we write and every app we use, every software running on a computer, none of it could exist without the compiler silently work behind the scenes. It takes human-friendly high-level code and transformations it into pure machine instructions. Without this, translations layer, even the simplest hello world couldn't work. So why compiler matters? It translates human code to machine code, improve program speed through optimization, ensure our code runs efficiently on hardware, make modern software development possible. So I'm Racha Riyad, and today along with my teammates, Shubhajit Mojumdar, Saiful Hassan, Sifat, and Muhua. And our presentation is presented to our honorable teacher, Ms. Drishti Shah ma'am. So, the compiler crucial role. Now let's look at what a compiler actually does. Is a compiler convert language like C, Java, Python into binary and 0s to and one is that CPU understands. For example, there is a summation code in C, integer add int a in B, return a plus B, which means we can take two values as an user input, and then it will do the summation of a plus b. And the simplified version in assembly code of this is add eax and edx, where a and T R summation and RET. That's how the logic becomes machine action. The compilation pipeline lexical analysis breaks the code into tokens, parsing, create a syntax tree, optimization, make the code faster and more efficient. Code generations produce final machine instruction. So the next slide, boosting performance optimization strategies, one of the most powerful feature of compiler in optimization. So eliminate redundancy, remove unnecessary computations, it removes unnecessary computations, constant folding, it calculates constant expressions at compile time, and loop transmissions restructure loop for faster execution. Efficient memory access minimizes extra memory optimizations. These techniques makes program run faster, smoother, and smarter. My ending part is this was the core idea of how compiler translate our code and optimization and performance to make modern software possible. So I would like to call my next friend Mohua now. Thank you very much.
Thank you, Ria. Assalamu alaikum. I am Ashrat Jahan Mohua. My ID last three digit is 968. In this slide, I will explain how compiler make cross a platform development possible. A single code base can compile to run on multiple operating systems such as Windows, Linux, and Mac OS. Even though the source code in the same, the compiler generate platform specific executable. For example, EX for Windows and ELF for Linux. This process not only ensure compatibility but also help developer reduce maintenance effort and maintaining one codebase instead of multiple versions, make develop faster and more efficient and less error prone. Next. In this slide, focus on how compilers support mobile app development. For Android, Kotlin or Java code is compiled into a bytecode and later optimized by the ART runtime and ensuring smooth performance across different devices. For iOS, Swift code is compiled directly into a ARM64 machine code, allowing app to run a native speed of Apple hardware. Finally, compiler generate the installable app packages, APK for Android and IPA for iOS. This completion process ensure high performance and efficient resources uses and consistent users experience on mobile device. Thank you for my and now I would like to inviting my next teammate.
First, let's talk about the JT compiler. JT means the just of compiling the whole program before running. It is the simplest and fastest way to A JIT compiler compiles the code while the program is already running. Why it is so useful? Because compiler watches which function of part of program are used again and again. When it finds something it run many times, it turns into a part fast machine code. This makes the program so faster. We can see JIT compiler in many real-time example like Java virtual machine uses JIT speed up Java program, and .NET platform uses JIT language like C hash, and the browser like Google Chrome and JIT inside the V8 JavaScript engine to make the website run quickly. And please go to the next slide. Then we come to the compiler in game development around physics, 3D graphics, movement, sound, AI, and many other things in same time. To keep the game running smoothly, game uses the engine uses compiler to convert the developer script into very fast native code. Native code means instruction that the computer can run directly without delay. This important for keeping the FPS stable. If the code is slow, the game will lag. Here is a simple example of typical game script like void, update, transform, translate, and there is some parameter. And this look very simple. It just move an object forward, but the game engine compile takes the simple line in turn into highly optimized machine instruction. It removes unnecessary work and makes sure that the movement is smooth very frame. So without compiler, game would not run slowly, feel heavy, and drop frames. With compiler, game run fast, smooth, responsive. So we can say that in short that JIT compiler make every day program faster, and the game compile help game run smoothly. Both are important for performance. That's all about my topic. Then my other team member Shubhajit will show his slide. Thank you.
Thank you, Saib, for calling me, and thank you, ma'am, for giving me opportunity. I am Shubhajit Majumdar, and my ID is 23215 246. My topic name is Embedded Systems and IoT Development. Today, I will talking about how compilers play a crucial role in embedded systems and the Ethernet of Things. The IoT ecosystem realize having on embedded devices that operate with very limited memory and processing power. Because of this, these systems depend on highly optimized compilers that can convert high-level languages such as C or C++ into extremely efficient framework. There are several important points to highlight. First, compilers for embedded systems transform C or C++ code into low-level machine instructions and directly interact with microcontroller hardware. This means the compiled code becomes the actual framework of controls or sensors, actuators, and other electronic components. Second, these compilers generate instructions specifically tolerate of chips like ARM, Cortex, M, AVR, and similar embedded processes. And my next slide is and my next slide is safety fast compilers in critical systems. Now let's look at a different class of compilers, those used in high security and safety crucial environments. These are systems where failure is simply not an option, and the compilers used here must reliability, predictability, and full verifications of the generated code. They are essential in industries where human lives or vital infrastructure depend on correct software behavior. Safety critical compilers are used in aircraft flight control systems, medical devices such as such as pacemakers and surgical robotics, as automotive electronic controllers units. In these situations, even a minor software error can have serious consequences. Second, this compiler must comply with strict safety certification standards. Example include DO178C for aviation and software, 1SO26262 for automation safety, and IEC 6234 or 304 for medical devices. Every step of compilations processes must be documented, tested, and proven safe. Thank you all. And my next team member is Sifat Mahmoud Shahan.
Thank you, Shubhajit Mandar, to giving me opportunity. Assalamu alaikum. My name is Sirat Mama Shaun. My ID is 232156163. So today I'll talk about how modern compilers improve AI and machine learning performance. AI models run faster and more efficient when they are optimized for the right hardware. That is where special AI compilers are used. AI compiler run faster and more efficient the hardware and adjust natural network models for CPU, TPU, and custom AI chips. Because of this, we get benefit like operation fusion and reduced memory transfer and better hardware utilization. Some popular example of this AI compiler are TensorFlow, XLA, and PyTorch, Glow, and Apache TPM. They help AI model run faster and use fewer reduce. So next slide is. So next slide is my future compiler and future compiler is smart all driven compilers. Now the future compiler is moving towards all driven and system. In this approach, AI itself the guide compiler chose the best optimization and strategies. We are also seeing the performance in natural language to code where AI can generate code from the simple English description. Another exciting idea, self-optimization code base, where the code and optimization itself automatically and reduce for need the mature adjustment. Overall, this is improvement aim to increase developer productivity, making it easier and build faster and high quality software. So this is our topic, and thank you everyone.